Hi, so in this short video I'm gonna show you how to build this ChainLink asset. Very simple model. We have few control about the size of the link, the offset of the bevel, of course, the number of subdivision, and all the basic kind of control you want to get with this kind of asset. You can change the other bevel size. And there is some constraints, so you never go, the bevel cannot go higher than a certain value, so you don't create overlapping geometry. Very simple asset, but it requires a couple of nodes and a few expressions here and there. So we can start with a geometry node and drop a grid on YZ position, YZ plane. So I will mainly use the sweep operator to actually sweep a profile along this this polygon. So I will first drop a poly bevel on the grid, so we can have I will apply it on point, and we can have already a little bevel. The grid, I will change the size a little bit. I don't like to get the same value on a X and a Y, especially if you want to resolve some constraint problem, because it might work with one grid, but yeah, just having different value for starting with. And so yeah, the sweep operator use mainly to your input. You've got the path and a profile. For the profile, I will also use another grid. Again, I will change the size, and we can plug that in. So it's almost there. We change wire. So that's gonna be the profile that we can then skin to create the geometry. So first thing we have to fix, of course, is the we have to change the position of the grid. So I will use a transform node and change the Y value. Okay, so eyeballing it. So that will be perfect, except that I don't want to use an eyeball value. So here is the first expression we need to use, $r y min, just to be sure that the grid is fitting on the ground like this. So whatever the size I'm using, it will always be on the ground, and it will avoid to have this overlapping problem here. So in the sweep operator, you can output a skin, which is lofting all the profile, and voila. So the basic system is already almost done. After that, we just use a copy transform, for example, to clone the link. We try 10 and change the translate and do a rotation, recursive rotation. So that's it. So now it's not very clever. We're gonna use some constraint and channel referencing. I will change the number of copies for the moment to 3. We can use packet instancing, just the Houdini instancing system. So first thing we need to fix is this bevel. So yeah, if I go, I will show the point. If I try to increase this value up, you got this kind of problem appearing. So we need to control the size of the bevel. And we'll also want to create a controller node where we can create a small interface so we can have controller in one single node. So to make it more clear, in every node you can actually mess with the interface. So the interface of the node is here, and you can drag drop additional controller inside this node. Common usage is to use a null object as a controller node, just to have a small interface here. And so I will edit. I can hide these two nodes for the moment. I don't need it. It's going to be just a controller, and we can drag and drop, for example, to float to controlling the size, for example, of the link. So we can change the label, link X, for example. I kind of like to use the same name. So that's the name of the label. If I play, so the label here, and that's the name of the internal channel. And I like to get the same name if I can. I will already do some restriction. For example, I don't want to have a 0 value for the size. Doesn't make any sense. So I will clamp and give a minimum value. Maximum value is going to be 2, but it's something you can go over it. It's not clamp, it's open. And I can just duplicate this one, and that's going to be the Y size of the link with the same restriction. Hit apply, accept. So for the moment nothing happens. Of course, we have to link this controller to the grid size. So we have used 1.5, so I will start with the same value. And for linking controller, linking channel, you just hit copy parameter, and for the target, past relative reference, and for the Y, it's going to be the Y. So now I can control the size and the height of the link. Perfect. So to fix the bevel size, we're going to use an expression. So what's happening is that what we want is the bevel size cannot be higher than half of the size of the smallest edge. Yeah, I'm trying to do my best here, but yeah. So here, after 0.5, we cannot go higher than 0.5 because 0.5 is actually the half of the size of the smallest edge. We don't know yet what is the smallest edge because it's a value that can change. So we can use an expression called min. So min will return the smallest number between two inputs. So the first input is this. So copy parameter, past relative reference, and of course the Y1. So, and as we said, we are doing bevel on both sides of the on the 4 point, in fact. So we need half of this value. Sorry, multiply by 0.5. So what's happening here is that whatever the size of the grid, that's the max value of the bevel. So it gives some kind of constraint. Pretty cool. When the bevel is at max value, there is an overlapping of points here. It's not super visible, but yeah, you can imagine that there are 2 points here, of course. So we can fuse the results. And now we can use multiply this bevel with a value between 0 and 1 to get the smallest and the biggest bevel. So again, not super clear, but I will just add a float. I will call that offset link offset, which is the size of the bevel. Same for the parameter, and I will clamp it between 0 and 1. Apply, accept. So copy parameter, and I will multiply this. So now the controller here, I can change the bevel size, and I can not go over the restriction we created. Let's see the result of the sweep. So that's nice control. So I of course also want to have a bevel, an inner bevel and an outer bevel here, and for doing that I will group. So that's my profile. So the inner point is going to be these 2 points here, and the other point, the 2 points here. We will try first. So I will select these 2 points, and I will group them in a group that I will call inner, so I can bevel them. I usually hate to do direct selection or grouping, but here I will never change this polygon, right? So it's safe to do it that way. I will use a color node to be sure that I'm working on the point I want, inner, and we will add a reddish color on it, and a sweep. So yeah, so that's the inner part of the model, and I will of course create an outer part, and hey, okay, did I select edges? No. So the other, oh yeah, it's going to be 0, 1. I don't know why I have, it's like an edge. Okay, so I can change this. No, the color, sorry. Just check my groups are working. Yes, that's the other color. So now the idea is of course to bevel the inner. So poly bevel. So poly bevel works on point 2, but for some reason the group doesn't appear. So I have to type it to force. And now you see I can get my bevel, inner bevel working. See the results. So again, we need to fix this overlapping system, and we're going to use the same trick. But first I have to drop a few control. So I will edit my parametric interface, and again I want first control the size of the profile. So I will add where is it? Sorry, okay, a separator just to have a small space between the parameter, and I will drop a float, and I will call that one profile X, and yeah, first again I will clamp the range 0.5 as a minimum value, open 2 for the highest value, and now I can duplicate this controller, call it Y, apply, accept. So the grid was about 0.5, 0.25, 0.5. I can copy parameter, paste relative reference. Hold on. Keep it. And for the Y, I know that I take the same naming convention, so Y. So now with my controller, I can change the profile size, and for controlling the bevel size. So what's happening here is that I want to have it, it's going to be slightly different because we are only beveling the two upper points. So the constraint is going to be half of the size of the X value. So it cannot go half of the size of this size here, the X. And for the Y, well, it's the full Y. So not super clear, I know. We'll pick, so X, we said that, okay, copy parameter. Again, minimum function between what? Half of the size of the X length. So multiply by 0.5. And the other one is the full Y position, Y size. Copy parameter, paste relative reference, and again at full max value we can have overlapping points, so I have to fuse this. So now what's happening? Again, if I take my controller, the bevel here cannot go higher than the smallest edge, and yeah, you get the same kind of control here as we did for the link path. And you see, if you go smaller, so that gives a nice control. And again, now I will just use a multiplier for that parameter. So I can go in my controller, edit parameter interface, and what do they call that? Setup. So I will drop a float. We can call it profile in offset. A range camping between 0 and 1. Apply. Yeah. So copy parameter and then multiply the result. So my controller now I have 0 and 1. At 1 is the max bevel size I can get with that kind of shape. Another thing I want, of course, to have is controlling the number of points. So that's the polybevel division. I'm gonna do that a little bit differently. So again, edit parameter interface, and what you can do is to drop parameter inside the interface directly, except that by default there is a restriction that we have to first go in this small gear here and disable this 4-bit linking parameter from outside this subnet. And now I can just drop inside the interface. I will call it inner. I think they call that offset, so I will just keep the same name. Just so now in my controller I've got the inner, And actually we forgot to do it for this one, for the profile, for the path. So easy, I can edit parameter interface. Again, as by default it's always on, so I can take now my poly bevel, the number of subdivision, and I can drop it here. Link subdivision, apply, accept. So see the results, and in my controller now I have also control of the number of subdivision for the link. Almost finished, so we have to do another poly bevel for the other part. Poly bevel, and this time we use the other group. So we see. Okay, so I will change the size of this one. Oh, what? No, I'm gonna use max size, for example. So again, we need to do constraint of on this one. This is gonna be the toughest, the most more complicated expression. Well, actually, it's always the same idea, of course. So again, the restriction is going to be the x distance by half is going to be the first restriction for the minimum expression, and then we need to also for the second input of the minimum is the distance here. So the height of the profile minus the bevel we already created here. So minimum between the x, that's easy, the x size, past relative reference, multiplied by 0.5, and then for the second input is the y size, copy parameter, minus the bevel, the previous bevel size, so it's over there. So as you can see, the whole expression here is evaluated, and if you click on the small, I don't know how to call that box here, you can see the value. So what we can do is, if we copy this parameter, we will get the size of the previous bevel as a reference. So seems to work. I will change the number of subdivision for, and I will fuse it again, the result. Let's try this. So I haven't exposed the second bevel yet, but so I can change the inner bevel. Oh, I will probably change the size here. Voila. So the first bevel is created, and then the second one use the max size that is allowed without creating any overlapping. It's a very cool constraint. I have to expose this this value again, so in my controller for the other bevel, edit parameter interface, I can use a separator first. So I first want to create a float for actually it's called inner bevel offset. I will copy this name, and it's not the inner, it's the other offset. Yeah. Between 0 and 1 is going to be my multiplier. and I will disable this because I will drop also this division. Over there. So now in my controller, and of course I have to, this offset is going to be the multiplier copy parameter for this expression, which is already a long expression. Okay, so yeah, you can, with expression like this, you can hit the Control E to have an editor, which is easier to type, of course, the expression, except that you cannot paste stuff. So there is no way to paste relative reference, so it's quite useless, in fact. So yeah, nothing is perfect. So here is the results. What we have in the control, in the controller. So you have the inner bevel, where you can go until it reaches the max value here, which is the center. So you have a perfect half sphere bevel here. And then for what's left, you can also create a small bevel, and you cannot go higher than the max value. And you can change the number of divisions. I can remove this color node. So voila, that's it. Maybe the last thing you can do. Oh yeah, we're gonna fix something. Here we have eyeball the translation for the copy, and we don't have to do that, of course. The offset is gonna be the size, the Y size of the link. So copy parameter, and translate paste relative reference. So it's gonna always be perfect. And now we can change maybe some value, like a bit somewhere, and we have all the control. You can also, of course, expose the number of copy if the controller, if you want, and yeah, maybe do a sliced eng variation like 93 or 80 to have a bit of, you know, twist effect. So that's it. The graph is actually pretty simple. You easily see the flow, and yeah, I'm actually building this kind of truss is exactly the same process. You know, okay, it's a little bit longer, of course, but again, with cool thing is that I have one single parameter that controls the length of this structure, and if I change it, everything is resized and duplicate. It's gonna take a little bit of a smaller time to compute, but so yeah, pretty cool. That's it. Hope it helps a little bit. Bye.